Hello everyone, today we'll talk about motion. So before starting this motion, let me explain a few basic things that you need to know. All physical quantities, what does mean physical quantities? Everything that we use in terms of physics, let me write it here. Physical quantities, all physical quantities, it can be mass, for example, mass is physical quantity, velocity, everything that you know about physics, temperature, what else we know, time, energy. There's so many, so on. We call it simply physical quantities, and all these physical quantities can be divided into main groups. First one is scalar quantities. Second one is vector quantity, and the vector. All quantities can be divided into groups. Scalar is just number. If you have a physical quantity such as mass, for example, just number, mass equal to 1 gram, this information is enough. With just number, sometimes we call it magnitude. Example, it can be mass, for example, 1 kilogram. That's all. We understand what is 1 kilogram is. Time, we will be there after 10 minutes. That's all. This 10 minutes is enough. What else we can say? Distance, 10 meter. That's all. This information is enough. It means these physical quantities belongs to scalar group. No direction, basically. There are some physical quantities that need direction. Without direction, information will not be useful. For example, and we group it, we call it vector. So basically vector quantities, these are such physical quantities that comes with number, or we call it magnitude, and also with direction. There are some physical quantities without direction, it's useless. For example, velocity, 10 meters per second, for example. This 10 meters per second, 10 is just a number. Also, we need direction. It can be moving to the east, west, upward, downward, to Nur Sultan, to Almaty, to Kuzlorda, etc. So without direction, this velocity is useless. It means it should come with its direction. For example, force, 5 newtons. This 5 is number. Direction is also important because force is coming with direction. For example, you are pushing, you are pulling something to the right, to the left, upward, downward. Direction also important. These are some examples. Displacement, acceleration. These are the vectors. So basically all physical quantities can be divided into groups. First group, scalar. Second group, vector. We call it vector. Scalar, these are the physical quantities with just magnitude. It means number. Just number is enough to understand it. Mass, time, distance, energy. Vector group, they should come with direction also. number, magnitude, and also there should be information about direction. Velocity, for example. My car is moving with 100 km/h to the Almaty, to the Kaskelen. So this to the Almaty, to the Kaskelen is basically information about direction, force, displacement, acceleration. Now let me give you some main difference between scalar and the vector. Why direction is important. So first of all, let's start with scalar. Scalar quantity. As example, let's take mass. Yes. Let me give you a simple example. We have an object. Mass of this object is 10 kg. And let's add to this object another object with mass is 5 kg. What will happen at the end? You will have big object mixture. Total mass will be 15. Yes, it will be 15. There is no another way. You will get exactly 15. There is only one answer. This is a scalar. This is a mass. Mass was just one example. Now let's come to the vector. Vector. As example, let me choose force. You know what is a force. So again, let's give as example two forces. F1, this is the first force, 10 Newton. And we have a second force, 5 newtons. For example, what will be resultant force, or what will be summation, addition of these two forces? Basically, question is find F1 plus F2. What will be your answer? Here, answer can be 5 newtons, or answer can be 15 newtons, or answer can be any number between these two numbers, 5 and 15 newtons. Why? Because of direction. Because of the direction. Question was find F1 plus F2. There wasn't any information about their directions. We don't know their directions. Let's say if F1 is directed to the right and F2 is directed to the left, for example, then what is F1 plus F2? Of course, it will give you 5 newtons, yes, and the direction will be in this direction. So let's say F1 was equal to 10 newtons, F2 equal to 5 newtons, and for this specific case, F1 plus F2 will give you 5 newtons, and direction will be to the right, because F1 10 newton is bigger than F2. Now let's say F1 was directed to the right, equal to 10 newtons, F2 also to the right, and this F2 equal to 5. What will be resultant force? It will be also directed to the right because of direction, yes, both forces acting into the one direction. So resultant force will be equal to 15 newtons. So as you see, for vector, direction is very important. So when you add two vectors, you should be careful, because you need to consider, you need to take in account the direction of the forces, the direction of the vector. So this is what you should keep in your mind. Later, of course, we will discuss it with details. For now, it's enough that vector is physical quantities, which is coming with magnitude, number, and also direction. Why direction is important? Because of this example. Yes, this example was just to explain why direction is important. For scalar quantities, direction is not important because it's useless. Mass, for example, 1 kilogram plus 3 kilogram, it will give you 4. There is only one way. For example, 1 second plus 10 seconds, it will give you 11. There is no another way. Now, this is just beginning. This is just beginning. So let me give you one more small information that will be useful, I think, in future. Any physical quantity. For example, let's take the mass. Mass equal to 3 kilogram. Mass is 3 kilogram. Mass is a scalar. What is a 3? 3 is a number. Or it has a special name. We call it magnitude. Sometimes we call it magnitude. Or just value. Yes, it's number, magnitude, value. What about this kilogram? Kilogram is unit of the mass. Of course, this kilogram is just one unit. It can be gram, yes. It can be milligram. It can be tons, etc. There are so many units. All these things are units for mass, for units of mass. So basically, all physical quantities comes with number, magnitude, and also it comes with unit. For example, kilogram is unit for the mass. Centimeter is unit for distance. Second is unit for time, etc. Now we have a SI units. What is a SI units? SI means international standard units. As you know, in this world, there are so many different languages, so many different countries, but they are all studying physics, math, biology, etc. So somehow they should communicate with each other. Yes, America, UK, Kazakhstan, Russia, China, India, Malaysia. They should communicate with each other. All these scientists, researchers. So it means they should use same language. For example, we use English. Why? English is popular, famous languages. But for physics, we should also use same language. I'm not talking about English language. I'm talking about in terms of symbols. Yes. So, for example, we use meter. If America uses centimeter, it will be difficult to understand each other. So all scientists agree to use SI units, international standard units. For example, for mass, international standard unit, SI unit is kilogram. For time, SI unit is second. For distance standard unit is meter. These are the main SI units. Mass, kilogram, time, second, distance, meter. All other physical quantities, velocity, acceleration, force, they can be described with these three main SI units. Okay, so don't forget about it. This is very important. So try to use SI units for all problems. Now let's continue with kilogram, for example. Mass. Shortly we say M. Yes, M equal to 1 kilogram. Of course, there are so many different masses in real life. Yes, mass can be equal to 0.001 kilogram. It can be equal to 0.0000 so many 0.1 kilogram. Yes, or vice versa. It can be 1,000 kilogram or 1 million kilogram, 1 billion, trillion, etc. So as you see, there are so many range is very big. It can be very small mass, it can be very huge, big mass. So of course, as you see, it's inconvenient to use these numbers, yes? So kilogram is not useful for this kind of situations. To solve this kind of problem in physics, we use prefix. Prefix. What is a prefix? Prefix is, let's say, types of units to make it useful. For example, giga. Gigagram, for example. Yes, giga, it means 10 to the power of 9. And symbols that we use to describe giga is capital G. For example, gigagram. Gigagram equal to 10 to the power of 9 grams. For example, gigameter. Yes, gigameter equal to 10 to the power of 9 meter, etc. So we use this kind of prefixes. Let me write some prefixes that will be useful in future. Prefix, name of the prefix, power of 10, and abbreviation. Abbreviation means symbols that we describe it. Abbreviation. Giga, it means 10 to the power of 9. 10 to the power of 9, capital G. Next one, mega, 10 to the power of 6, abbreviation capital M. Kilo, 10 to the power of 3, small k, symbol. Centigram, centimeter, 10 to the power of -2, small c. Then milligram, millimeter, milli, 10 to the power of -3, small m. Then micro, 10 to the power of -6, mu, yes, we call it mu, and the nano, 10 to the power of -9. We use symbol small n to describe it. For example, kilogram. So let's use kilogram. It means this is how you need to use. Kilogram, kilo, kg, kilo means g, gram, equal to 10 to the power of 3 grams. It means 1000 grams, yes? For example, kilometer, 10 to the power of 3 meters. Micro, this will be milli. Micrometer. Micrometer means 10 to the power of -6 meters, etc. This is how we use it. Also, we have some complex, difficult units. For example, unit for velocity. What is SI unit? Of course, meter per second. Yes, this is SI unit. Meter is SI unit. Second is SI unit. But of course, we have different other units for velocity. Millimeter per second. It can be kilometer per second. Decimeter per hour, etc. How we can convert it? How we can convert from one unit to another unit? For example, let's start from the famous ones. Yes, the first one. Let's say we have 100 kilometer per hour. How we can convert it into the meter per second? So we need to keep number, magnitude, which is 100 for this problem, and this is 1 kilometer basically. 1 kilometer is equal to 1000 meters. Yes, so we will replace kilometer with 1000 meter basically, and divide 1 hour. In 1 hour, how many seconds we have? 3600 seconds, which is equivalent to the 1 hour. So basically we are replacing 1 hour with equivalent second. That's all. This is how it works. So firstly we need to just multiply, divide, that's all. So we can remove 2 zeros, so it will be 100 times 10 divided by 36. Unit will be meter per second. And the final answer, 1000 divided by 36, it's 27.7 approximately. So we can say 100 kilometer per hour equal to 27.7 meter per second. This is a method how to convert from one unit to another unit. Let me give you one more example. Acceleration. Unit for acceleration, meter per second square. This is a SI unit. So it means it can be kilometer per hour square. Yes. So let's convert from kilometer per hour square to meter per second square. Second square. Let it be 1000 kilometer per hour square. We have this kind of acceleration. Now we need to convert it into the meter per second. So we need to keep the number magnitude 1000. 1 kilometer is equivalent to 1000 meter, and the 1 hour is equivalent to 3600 seconds and the square. So first is just simple math. 1000 times 1000, 1 million meter divided by 3600 square. It will be big number, 1, 2, 9, 6 and 4 zeros, second square. So final answer will be 1 million divided by 1,296, 4 zeros. It will be 0.077 approximately meter per second square. So this is how it works. And you should remember that UK, United Kingdom, America, they use slightly different units in daily life. For example, inch, miles, miles per hour, etc. Maybe it will be useful. I will write it here. For example, 1 inch equal to 2.54 centimeters. 1 mile, mi, equal to 1.609 kilometer. 1 mile per hour, 1 mile per hour equal to 0.447 meter per second. 1 meter equal to approximately 39.37 inches. 1 kilometer, so this is vice versa, yes, 1 kilometer equal to 0.621 miles. And the last one, 1 meter per second equal to 2.24 mile per hour. These are some units that might be useful during our courses. Now you have a task, classwork, let's say. So you need to do these examples. Example number 23, 24, 25, 26, and 27. Here there is something that I did not explain to you. This is about significant figures. So your job now, find and learn what is a significant figure. You can Google it. It's not a problem. Try to understand what is a significant figure. Then do these examples: 23, 24, 25, 26, 27, and let's see, and the question 32. Question 32 is very interesting question. You can find some informations from the Google, from the internet. So read it carefully. You can use internet, you can use Google.